Wow, look at the warm water flow across the Pacific. And whoa, the storms are getting much stronger.
Hey everyone, and welcome to The Explainer. So today we're diving into something absolutely wild. We're talking about an invisible force, literally a giant natural engine that controls the weather all over the planet. It's this massive climate cycle hiding right there in the ocean, and it can completely flip what it looks like outside your window, whether you're in North America, Australia, or anywhere in between. By the time we wrap up here, you're going to be able to predict the weather better than most adults. Let's get right into it. Okay, imagine this for a second. How in the world could extreme weather on totally opposite sides of the Earth possibly be connected? Think about it. You've got a bone-dry, dusty drought sparking huge bushfires in Australia, right? But at the exact same time, thousands of miles away in Peru, there are these massive pouring rains causing incredible floods. There's no way that's just a coincidence, right? And it's not. They're actually linked together by one giant weather machine hidden deep in the Pacific Ocean.
So to really understand how this machine works, we got to travel back in time a bit. Long before we had fancy satellites floating up in space, Peruvian fishermen back in the 1600s were out on the water every single day. And over time, they noticed something super strange. Every few years, right around Christmas time, the ocean water, which was usually freezing cold, would suddenly turn unusually warm. Since it always seemed to show up right around the Christmas holiday, they named this warm current El Niño, which is Spanish for the little boy, referring to the Christ child.
Now, I know a warm bath sounds pretty great, but for these fishermen, this warm water was absolutely terrible news. Normally, that freezing cold water brought up tons of yummy nutrients from the bottom of the ocean, which meant massive schools of fish, like anchovies. But when El Niño rolled in, that warm water kind of acted like a playground bully. It blocked the cold water from coming up, chased away all the nutrients, and sent the fish swimming off to find better food, leaving the poor fishermen with, well, completely empty nets.
So what's actually causing this? Well, think of the Pacific Ocean like a giant bathtub. Normally, you have these winds called trade winds that blow across the ocean from east to west. They act like a massive fan, pushing all the warm surface water over toward Asia and Australia. But during an El Niño, that giant wind fan just kind of weakens, or even stops completely. And without the wind holding it back, all that warm water sloshes right back across our giant bathtub towards South America. And here's the real kicker. Wherever that warm water goes, giant storm clouds and heavy rains follow right behind it. Just take a look at the shaded areas on the screen here. Today, scientists don't use fishing nets to track this stuff. They use incredible data to map out that giant blob of sloshing warm water as it moves across the Pacific over several months. You can actually see how that shaded blob creeps eastward, totally changing the ocean's temperature as it goes. That moving blob, that is the literal engine of El Niño.
Moving on to Section 1. Enter the little girl. Meet La Niña. But wait, El Niño isn't an only child. See, when that giant ocean seesaw swings completely in the opposite direction, these two siblings actually trade places. A totally new pattern takes over, called La Niña, which translates to the little girl. And let me tell you, they have entirely opposite personalities, and they take turns bossing the ocean around every few years. As you can see on the left, El Niño means weak winds and warm oceans. But on the right, La Niña turns that giant wind fan on super high. It blows way harder than normal, pushing all the warm water extra far away, leaving the ocean near South America unusually freezing cold. It's basically an endless game of climate tug-of-war.
All right, Section 2, the domino effect and its global weather ripple effects.
Now, you might be sitting there wondering, why do we even care if the ocean gets a little warmer or colder thousands of miles away? Well, it's all about the domino effect. You know when you line up a huge row of dominoes and tip that very first one over? That single change in the Pacific Ocean is the first domino. When it falls, it knocks into the atmosphere, totally altering the paths of those giant winds up in the sky known as the jet stream. So when El Niño throws a tantrum, we see some truly dramatic stuff happen. That sloshing warm water brings intense, dangerous floods and landslides to Peru and the southern United States. Meanwhile, because the rain clouds literally left them behind, places like Australia and Indonesia get stuck with terrible droughts and raging bushfires. And under the water, the extreme heat actually causes beautiful coral reefs to lose their color and turn completely white, a really sad process called bleaching. Plus, marine animals are forced to migrate thousands of miles just to survive. Let's take a quick trip back in time to see exactly how humans figured this massive puzzle out. Tracking through history, it obviously started with those observant fishermen in the 1600s. But it wasn't until the 1920s when a brilliant scientist named Gilbert Walker started looking at weather records from all over the world that he discovered the atmospheric pressure was literally seesawing back and forth. Finally, by the 1980s, scientists at NOAA, the National Oceanic and Atmospheric Administration, built an incredible network in the ocean to watch the whole thing happen in real time.
But why did scientists push so hard to figure this out in the first place? Well, history showed us just how dangerous this weather machine could be. Back in 1877 and 1878, the Earth experienced what is still considered the strongest El Niño on record. It swung that weather seesaw so violently that it triggered a brutal global drought. Crops completely failed all over the world, leading to terrible famines that tragically affected over 50 million people. That's a mind-blowing number. It was a massive wake-up call that humanity desperately needed a way to see this invisible force coming.
Which brings us to Section 3, predicting the next event with high-tech ocean spies.
So, how do we see the next El Niño coming today so we don't get caught totally by surprise like people did in the past? To solve this mystery, scientists had to get pretty creative. They built something called the Tau Array. Imagine a giant network of high-tech robot buoys just floating out there in the middle of the remote Pacific Ocean. And these aren't just your standard floating markers. They are literally deep-sea weather spies. They constantly measure the water temperature, wind speed, air pressure, and then they instantly beam all that information straight up to satellites in space. And as you can see here, this brilliantly illustrates what those robot spies help us create. By reading these squiggly lines and data charts, meteorologists can track exactly what the ocean is doing right at this very second. Because of this amazing technology, we don't have to wait for the fish to disappear to know El Niño has arrived. We can actually predict these massive droughts or heavy floods up to an entire year in advance. This gives farmers crucial time to plant different crops, and it gives cities time to prep for big storms. A real game changer. Which leaves us with one final, super important mystery to solve. See, the El Niño and La Niña cycle is completely natural. It's been happening for thousands of years. But today, human activities are putting extra greenhouse gases into the air, which is making the whole planet warmer. So the big question scientists are desperately trying to figure out right now is this. As our world heats up, will that extra heat act like fuel, causing the little boy and the little girl to throw even wilder, more extreme weather tantrums in the future? It's a fascinating puzzle. And, maybe one day, one of you watching this explainer will be the exact scientist who figures it out. Thanks for joining me on this awesome climate adventure.
If you enjoyed this video, please like, share, subscribe, and hit the bell so you never miss a new lesson.